Hello, welcome to the very first science terminology video. And today we're going to talk about acids and bases. So we're going to cover what they are and some of the important things about them. So first off, let's talk about the definitions of acids and bases. On the acid side, there's two definitions. An acid could be a substance that donates a proton, so basically a hydrogen, an hydrogen atom, and that's the Bronsted-Lowry definition. And then the other definition, which is a little bit more broad, is any substance capable of forming a covalent bond with an electron pair, and that's called a Lewis acid. On the base side, a base is a substance that dissociates to form hydroxide ions, which are OH. That's Arrhenius's definition. And then the more broader definition that's used more generally is a substance that can accept hydrogen cations, and that's the Bronsted-Lowry definition as well. So Bronsted and Lowry both came up with these ideas at the same time, and so they're both attributed to them. Talking about acids more specifically, acids can be highly corrosive depending on the strength of the acid. They're very reactive with bases. They have a pH that's lower than 7. pH is just the scale in which we measure acidity. So if its pH is lower than 7, we consider that an acid. And if it's higher than 7, then that's a base. And then acids are often sour. So not that I would suggest that you ingest acid, but there are some acids that are safe to ingest, and they are often sour tasting. Think about lemons. Lemon has acid in it, and that's why it's so sour. Some common acids that you may know about or didn't know existed, but they are around you, are gastric acid, which is hydrochloric acid, and it's in your stomach. Sulfuric acid, which is H2S, and that's in car batteries. And then citric acid, which is in a lot of fruits. So that's also what can make things taste sour. That's citric acid. On the other hand, bases are very similar. They're caustic on organic matter. That means they're going to destroy things that are organic, so your body. They react violently with acids. They have a pH higher than 7, like I was talking about earlier. And bases taste bitter. So if you were to taste a base, not that you'd want to, it would be bitter tasting, generally. Here are some common bases that are probably around you. Maybe you weren't aware. Ammonia is a base, and it's in food and fertilizers and all sorts of different things. We use ammonia in a lot of stuff. Soap are bases. They're these long fatty acid chains that we attach a base to. That's what picks up the dirt and the grime off your hands, is that base. And then baking soda. Baking soda we use in cooking all the time, and that is also a base, right? The sodium ion on NaHCO3 dissociates, and HCO3 then acts as a base. So those are some common bases that you may be familiar with. Now, what do these acids and bases do? Well, the first thing that they can do is what's called a neutralization reaction, and neutralization is what happens when an acid and a base are reacted together. Neutralization reactions always result in a salt and water. So I've got a couple pictures here that show you that. In the first one here, we've got H and Cl, and they're going to dissociate. They're going to ionize in water. Same thing with KOH, right? We see this one is an acid because it's making hydrogen ions, and this KOH is a base because it's creating OH ions. And then when they react, the OH and the H come together to form water, H2O, and then the potassium and the chloride come together to become potassium chloride, which is a salt. And we have the same thing over here. We've got HCl and NaOH, which are kind of like the standard acids and bases, and when they combine, they make table salt and water, so some salt water. And that's what neutralization is. That's how you stop acid, by pouring a base on it of equal strength, or opposite. If you have a base, you pour some acid on it, and that'll neutralize it. Now, the other thing that acids and bases can do, which is pretty nifty, is called an equilibrium reaction. And equilibrium is what occurs when acids and bases are added in such a way to create a stable pH. And so, for instance, your blood is a acid-base equilibrium reaction. Your blood needs to stay at a pretty consistent pH so that it maintains its ability to do what it needs to do, and so it as well is an acid-base equilibrium reaction. So I've got a real basic one here with this acid and base combining to create the conjugate base and the conjugate acid, which has a very standard equilibrium. Same thing over here. Here's acid entering the bloodstream. This is how our body handles that. The carbon dioxide that we are creating through our energy processes is used to kind of absorb that hydrogen ion, and then it can be easily expelled as carbon dioxide. So that's how our body regulates and protects us from weak acids and stuff like that in our bodies. Thank you so much for watching this first science terminology video. It's been really great being able to make all these sort of things for the channel. I hope you've enjoyed them and learned something. See you next time. Got more in store. Bye.